So,
Hi everyone, good evening. Let us wait for a couple of seconds. So I think we can start. Hi everybody. Sorry for delay, by the way, because there was a problem on the arranging the exact time. So Sven here with us, and he is developer advocate from JFrog company. You know, it is very famous company. Known by the developers, and he will talk about DevSecOps topics. So, Sven, it's yours.
okay, hello from Germany. I hope you all are doing well. I assume you can hear me. You can see my slides. I haven't checked on YouTube at the same time, so I don't know. But if you have any questions, I will try to have an eye on the chat. So if you have any questions, so that I may try to answer this one. Otherwise, there are several things or ways to reach me. So let's talk a little bit about the topic. We are talking about the low-hanging fruits here, the low-hanging fruits of DevSecOps. And yeah, assuming the audience has a lot of knowledge about DevOps, I'm not sure who of you already played around with the security topic. So the questions I want to give an answer through today is what are the low-hanging fruits? So what's a quick wins? Means you have a DevOps environment and you want to start with a security topic. So what are the possibilities? What is the best way to start with is what are the quick wins? Means the easiest way to start with the most impact. And this is addressing everybody who wants to start with the security part. And yeah, we'll find a way to get the first things up and running. So, okay, then my name is Sven Ruppert. I'm the developer advocate for JFrog and I'm based in Germany. And since COVID, I'm mostly running in the woods around. And instead of going to conferences, I'm just recording a lot of stuff and pushing it to YouTube. And if you like to see Java related stuff or security related stuff, DevOps or DevSecOps related stuff, have a look at my YouTube channels. I have two. I've one, the German one for sure. I'm a German native speaker, so that's one thing. But I have an English one as well. So just search for my name in English or just my name, then you will find it. And I really would like to have you as my new subscriber. So if you like the outdoor style, perfect. And if you just want to see bushcrafting stuff, so nothing about technology, check out my private channel about outdoor skills. Okay, so you can win a JFrog shirt if you are live attendee here at this streaming, and if you're one of the first 15. So go to jfrog.com show notes. They will find, corresponding to this event, the possibility to win a raffle here to jfrog.co Istanbul t-shirt, and the first 15 will win a shirt. So try to grab one of them. Huh? So, what are we talking about? Security for sure. And I'm using cloud native as an excuse, but everything what I'm saying is not only bound to cloud native. Cloud native is just one way to look at an architecture and it shows or highlights a few things that are coming up more and more. But if you're in a traditional organization with monolith or whatever, you can adopt all this stuff, what I'm saying, in the same way. Don't worry. If you're looking at this cloud native stack, or if you're looking at the general topic of these applications, we have different layers and you have different possibilities that source code or that program can help you. So, and we have to think a little bit more about what are the different layers, where is the best place to start. For example, if you have this microservice or service-oriented architecture or whatever, then if you want to map a bunch of use cases, for example, to a bunch of microservice, there is no tool that will say, oh, use case A and B fits perfectly to this microservice, and this use case is a separate use case microservice, and so on, or function, or whatever. So if you want to divide your use cases in several parts, there's a machine that will do the job for you. You have to do it as a human. So you as a human has to decide, okay, I want to distribute use cases, and this is a good way. Thinking about security, yeah, what is the best composition of use cases in terms of business security, or making the information central at one place, or sharing information? This is something the machine is not able to help you. So you really have to think about the service-oriented architecture, for example, here, and what is holding which part. If you're going a little bit more to the communication itself, so you have now two services and you decided what is going over the wire, the machine is not good in telling you, oh, it makes sense to use these 3 bits of information to send it over the wire, and then your business is safe. And the security is not, or the tools is not able to help you to make a business case secure in terms of it couldn't be misused or it couldn't be compromised on a business level. So the communication between two services, this is a different thing. And here the computer or the program can help you more, the IT, because the tools can start encrypting channels, can deal with different keys and all this stuff. So it's a not the content, but the way how to exchange communication is something you can, yes, secure on a technical layer a little bit more. What we are learning from this one is, if you're talking about security, we have to divide it in different parts, concepts, and all this stuff, and technical or technical related stuff. And if you're going to this technical layer more and more, you will see that the programs and the tools and all this stuff is more powerful to support you. Going down to the container-based infrastructure, dealing with resilience and against now service attacks and breaking through this architecture in terms of getting user access in the operating system, all this stuff, it's way stronger, the tools, because they are just technical things and not this business related stuff. I think you got the point. But security is really, really strong inside the DevSecOps environment. And this is where JFrog is focusing on the DevSecOps part and on the container-based infrastructure. So delivering to a container-based infrastructure or delivering to production systems. But if you want to start with security, the really easiest part is if you're starting inside your development environment or during the time you are creating your binaries. So this, what is good and the bad part with this microservice stuff? So for all, we have this microservice shorter life cycles or release cycles. Means that you're writing something, you can push it to production. Okay, this microservice is not nice. There is something bad, and then you can just throw it away and rewrite it. It's good in terms of getting rid of old technology, but it's bad in the same way, because if you're changing technology, maybe you are not the senior anymore, who you are in the other one. So, for example, for me, I'm since ages in Java, since really ages in Java. I never learned Go. Means if I'm now writing a microservice in Go, it's fun for me for sure. I will learn a lot of stuff, but I'm a junior again. So not in terms of the language. This is not exactly what I'm meaning, but it's a whole ecosystem. So what is the best practice with a compiler? What are the good libraries? What's the trustable community inside the Go community? What are the good reference? And so on and so on. So you have to learn all this stuff again. Even if you're a really old senior in one language, you will learn very fast, but you will do a lot of these beginner mistakes anyway. So it means that having the possibility to go with the time to fast adapt to new technologies in the same way is dangerous, because you have to relearn a lot of stuff in this field. Thinking about microservices, functions, cloud native, whatever, what you can see in a composition of use cases is that we are going more and more to polyglot environments. But polyglot environments leading to polyglot attack vectors means that if you have different technologies and you're connecting different technologies, you have different ways to attack your system, and not only based on one technology, but on multiple technologies. And the attack vector could be quite complex. And this is not easy to understand. So you need tools that are able to deal with a whole package, not only one stack, not only one microservice, no, the whole impact graph of the whole architecture. So, and polyglot environments sometimes even inside a microservice itself. And so thinking about, for example, this open source tool Vardin. Vardin is from Finnish company, and they built this. You're writing a Java, your code, and it's translating it to, or not translating, it's building a web app based on web components, but you have written it down in Java. So it's not transpiling, it's just connecting two things. It's connecting Java with the NPM stack, and then you have HTML5, you have JavaScript, and the NPM stack, and all this stuff. So the developer will code in Java, but in the end, you have a stack that relies on the lifecycle Java, on the lifecycle NPM, the whole dependency management there, the whole vulnerability and compliance issues that you can have here, and so on and so on. So polyglot environments are sometimes even inside one microservice. But throwing everything away, what you see around this different microservices, monoliths, whatever, focus on one single part. So we're focusing now on one single application. If you're focusing on one single application, with every abstraction layer you're adding more complexity, different technologies, and so on. So if you have the application and there are vulnerabilities in, and you let it run inside Linux or an operating system before you use a virtualization technique like Docker or whatever, means that with every layer you're wrapping around, the vulnerabilities in the previous layer is still there. And it could be used direct or indirectly, but the vulnerabilities are there. So it means with every new layer, you're just adding vulnerabilities, even if you're adding zero vulnerabilities, but you're never removing vulnerabilities. And this is one thing that you should be aware always, that with every new wraparound, you're just adding vulnerabilities per definition. And the same with compliance issues. So talking about security means that we are not only talking about vulnerabilities and how to hack the system and all that stuff. It's fancy, sure. But on the other side, the compliance part is important as well, because the wrong license or the right license at the wrong place in your whole production line can be a huge damage to your whole organization, or can kill the project or even the company. So security means security in terms of being able to defend against and attacks in the same way as make your business secure in terms of compliance issues. And here, again, you have two layers. You have the domain-specific part. So tools are not good in making your domain-specific thing secure. So can I misuse this text rule to do something weird? But on the other side, the technical thing, can I prevent against, or can I defend against SQL injections? This is something that technology is good. So even here you have a two-dimensional thing. It means one thing is a domain-specific thing. This must be done by humans for sure. There is no really good tool. On the other side, the technical thing, tools can support you enormously. So, but the most projects, people, developer, whatever you want to say, they're forgetting one thing, and this is a whole DevOps tool stack. For this, just a short side note. You all heard more or less about this SolarWinds hack. What happened here? The company SolarWinds, they have 300,000 customers, and they have a product, and this product is managing networks. Okay, so this means the software, Orion platform is the name, will be installed somewhere in the network and is able to do a lot of stuff with admin rights, monitor things, reconfigure things, and so on. And if you have 300,000 customers, most likely the most customers are customers with huge networks, not with tiny networks, because then you're not buying this management software. Right? So what happened? There was a hacker group that broke in through into the system from SolarWinds, and the target was not to compromise a binary or to steal data or to destroy something. So no, this was not the target. What they have in mind is, or what they had in mind, is that they broke into the CI environment of this company. And there, inside the CI environment, they manipulated the CI environment so that with every release build, they start building compromised binaries by themselves. So they are just provided internally, and it was a little bit hidden. So the binaries they wanted to add inside the CI environment. One of the last steps was just grabbing this binary and adding it to the program. Okay, and then they had an automatic update. So they built a new release. It was already compromised binary. Then they offered it via an automatic update to all of their 300,000 customers. And in a few days, they infected over 15 or 20,000 networks, not servers, networks, because huge companies with huge networks are using this software. And this was more or less a disaster. So the attack was not against the final targets, the attack was against the supply chain. This is something we should be aware as a developer. So we are now the targets. And with this, we have two dimensions now. We have two dimensions, and this means the first one is that I need, or I have to make sure that I'm not compromising, I'm not using compromised stuff. On the other side, I have to make sure that I'm not pushing compromised stuff out so that I'm not a multiplicator. So we have now two attack vectors against ourselves, so protecting ourselves and protecting our customers or consumers of our software, even if it is inside the company. It's the next department. So the first question to you is, any one of you ever checked, for example, the Jenkins against known vulnerabilities? Who of you protected your compiler and all this stuff? So you have to make sure that the whole supply chain you have must be secured. And this against known vulnerabilities and compliance issues, but known vulnerabilities is here the big part. There's a term called shift left. Shift left is you should start as early as possible with the security stuff. It makes no sense to do it in the end. And for me, to remind what shift left means is I'm just rotating this picture of application, Linux, Docker, and so on. And shift left means going to the left. And the first thing what we're doing is we are writing an application. We are creating source code. So that's the earlier thing. And we really have to start there during the time we are writing software, not if everything is done and it's running. No, that's too late. We have to start as early as possible. What I'm excluding here is the concept phase, because this is something we have to do on a human level inside the organization, but we are focusing here on the technical thing. So having now in mind that we have all these different layers and we have all these different attack vectors inside every tech layer, we have to think about what is a composition per layer. So as the first thing is, if I'm writing a Java application, I have something that is managing my dependencies because I'm writing some piece of code. And the other thing is I'm using some dependencies. I will cover this in a few minutes. But what is sure is per layer, we have corresponding dependency managers because we are not reinventing the wheel. We are working with dependencies. We are grabbing stuff from outside. And this is for every tech layer. So the application may be in Maven, Linux is a Debian layer maybe, or Docker is a Docker repositories, Kubernetes, and so on. But again, the most people are forgetting, if they are starting with security, the whole tech stack. So all binaries inside this tech stack should be available in an immutable way or repository as well to make sure that there is no compromisation. So, okay, but if you're thinking about this single point that will try to help you to understand the whole tech layer, you need something that's able to understand every tech layer, and then you need something that's able to work with this metadata. We at JFrog, we have Artifactory, that's a binary manager or a manager for dependency managers. We have a different kind of repositories where all this meta information and the binaries are stored. And then we have Xray that is connecting through it and working with the binaries and the meta information to get the full impact graph. I will cover the full impact graph in a few minutes again, but have in mind that these are the essential tools to deal with the whole meta information, build info, and all this stuff in binaries. And on the other side, where's the possibility to have access to all layers. And don't forget your tool stack. This is really, really important. So don't forget your tool stack. Scan your Jenkins, check your compiler, check whatever. We have different terms, and if you start with security, there's mostly a challenge with different parts of the company. So how to implement security, what the best way. And one thing I always see is that there is a lack of wording. So a lot of companies are using more or less or describing the same mechanism using different words and so on. And here are two things that are highly recommended to think about and talk with the management, for example, about it if you want to start implementing security. The first thing is time to market. If you're talking to a management layer, time to market is very common for them. What they understood or what they're meaning with this is we have this use case, we have this description, then we have this time of creating this stuff, and then it must be as fast as possible delivered to the customer so that they can use it, the company can charge it. Okay, so if I want to get money for it, means I have to clearly envision what I need, and then I have this production phase, and this must be as short as possible and as cheap as possible, and then I need the possibility to use it. Why? Why? I never understood it. Why not thinking with security in the same way? So, what is security? Security is a requirement, like a use case. There is a vulnerability, for example. Then you have exactly the same behavior. It must be delivered as fast as possible to production, not the vulnerability, but the bug fix or the security fix. Okay. So you have the requirement, there is a vulnerability, must be fixed. Then you have the possibility to fix it. Then it must be as fast as possible delivered to production so that it couldn't damage, not get more money, but not losing more money. Okay. It's the same. It's just the opposite of it. Right. I see so often that process of there is a use case and then do it and push it to production and then we will test it. This is optimized, yeah, and then you can just do it. But for security issues, they have different processes, and then they have this guy must say yes, the next one must approve it, the next one has to do something. And then they have a really slow process of fixing vulnerabilities. And this is just a nightmare. So if you have the knowledge about vulnerabilities, then it's a requirement. Handle it like a requirement. Optimize a whole production line to get rid of this stuff as fast as possible and make sure that you have the same lean processes to push stuff to production. And as I mentioned, I see so many environments where the use case is fast, on a fast track, and security fix are on the slow track. This makes no sense. So talk about time to market with your management, with your lead or whatever, to get this thing done. Make this process lean, fast, easy, and fully automated. The next step is make or buy. The most people know, okay, we don't have this knowledge, and then we can hire an external and he will do everything great because he had so many experience and he saw it in so many different companies, and then I'm just paying money and stuff is done. Okay, that's make or buy on the economic part. Huh? And I think we all had our experience with this, the pros and cons. But we as a developer, we're doing exactly the same. And we have exactly the same issues. We are not hiring external, but we are using externals in terms of we are adding dependencies. And here again, it's the same mechanism and the same way of talking about the risk, the investment, and all this stuff. Should I learn this stuff by myself? Should I know enough about this technology that that I'm able to identify if my dependency or if this external guy is doing the right thing? How to make sure that I have a good amount of quality in my external dependencies, and I don't or I shouldn't reinvent the wheel by myself. So if I have no clue about how to create a PDF, then it makes mostly no sense to learn all the PDF specs, writing a PDF generator, and then doing this one. Because I know more about PDF after this for sure. I have a lot of security issues for sure, and then I have to maintain this stuff. No time for this. On the other side, if I'm adding a PDF library, I must be able to understand what is a bad thing in PDFs. Oh yeah, you can add JavaScript and then it could be executed. Okay, so you need to learn a little bit about PDF. Then you must be able to test and verify the functionality. And then you have to decide what's enough and what's a good dependency. So what is external you can trust? Okay, I think this is more or less clear. So we have to deal with dependencies and we should treat it in the same way. So don't add just dependency because, yeah, it looks nice and then do it. You wouldn't do it with an external consultant. Okay, you wouldn't just say, hey, yeah, looks cool, just do it and forget, and then firing the next one. Don't do the same stuff with your dependencies. Okay, we have different approaches inside the security area, and there are two main parts. One is a developer-centric part, it's SAST, Static Application Security Testing. The next one is the Ops part, more or less, a Dynamic Application Security Testing. And then we have a few combinations and RASP as a runtime protection. Okay, so what's SAST? With SAST, we mean that we are able to scan all static parts of an application and searching for known vulnerabilities. Okay, what mean known vulnerabilities? Known vulnerabilities are identified vulnerabilities with knowledge how to get rid of them, or there's a patch already, or whatever. So it's maybe not a patch already, but we know this vulnerability, what's going on. So these are known vulnerabilities. Then there is a certain amount of unknown vulnerabilities, and the unknown vulnerabilities is everything we don't know, and then we have to think a little bit about the balance between known vulnerabilities and unknown vulnerabilities. If I can trust different reports I had the chance to read, or different other companies that are doing way better research than me, because I'm not a security researcher in detail and I don't have too many statistical material. But what they are saying is that the whole amount of known vulnerability is just constantly growing. Okay, except because the known vulnerability is never removed. You have something against it, but the vulnerability is there. Okay, so this amount is constantly growing. And then the amount of unknown vulnerability is smaller than the amount of known vulnerability. First of all, the known vulnerability amount is constantly growing since a long time, and the amount of unknown vulnerability is limited by the people that are able to create no new vulnerabilities. And this is not a group that is exponentially growing, this amount of humans that are creating vulnerabilities. So the assumption is that the amount of known vulnerabilities is in some range, but more or less constant. But from this, step by step, the vulnerabilities are converted to known vulnerabilities, and this amount is constantly growing. Okay, having this in mind means that fighting against known vulnerabilities has the fastest and biggest impact, and this is something you need to do because this is growing anyway. Okay, so and this is where static application security testing is focusing on. So static application security testing is losing the dynamic context of an application, but it can search for already known vulnerabilities. And here you can scan 100% of the whole tech stack. Okay. The opposite is dynamic application security testing. For this one, you need an already running system. Thus, you can do immediately with the first line of code you're writing. You can start with scanning what you have. On the other side, with Dust, you need something that's running, and then it must run in the same context of the operation system you want to protect. So it makes no sense to have a Dust application where you're testing stuff, and in the end, you're using a complete different environment to run it. So you would lose a lot of the power of Dust tools. These Dust tools, they have this hack approach. They are looking from outside to an application and try to identify the weak points here. The attack vectors are mostly based on the most common vulnerabilities. Most common vulnerabilities that are defined so like secret injection, heat dump, so memory dumps and all this stuff. So you have a list of this one that are language neutral and mostly seen already. And then the weak point with Dust tools is, first of all, you need something that's already running, so it's very late in production. It's again shift left. The next thing is the tool needs, if it is just a software as a service thing, you need access to your application. It's way better if you have it on some production-like systems, because then you have the potential to identify weak configurations or open ports and all this stuff. And the next thing is most attack vectors are built based on this most common vulnerabilities, and there is a tiny chance to, or mostly no functionality to define your own attack vectors against the system. And if there's a new attack vector, it will take a bit time, not endless, but a bit time, depending on your service you're using, to adapt to this new attack vector. Okay. And then the next approach, if you have Zust and Dust, the next logical step was to merge both. It's interactive application security testing. So you're merging both approaches. It's like a security debugging of your system. So you're ramping up your application. You have full access to all components of your system. You're checking all binaries and all configurations, all this stuff. You're bringing it in a context, and then you're doing this Dust stuff. So there's most common vulnerability-based attacks, and then it is in a way that you can manipulate the attack in a way that you're identifying your individual attack vector against the system. So, and this is a B. So theoretically, this is a perfect thing, okay? Because it's just merging Zust and Dust. If you start with security, it makes no sense to start with interactive application security testing, because you need the knowledge how to attack, how to compromise your technology, and all this stuff. And most likely you need very highly educated people in this specific area to make the most usage of IST, okay, this interactive application security testing. These are the three testing things. So more or less two, Zust and Dust, and then the combination with your own attack vectors in IST. And then there is RASP, Runtime Application Security Protection, means that this system is used to identify an ongoing cyber attack. Means RASP is completely useless in test staging or even all the stages. RASP is only useful in production. Most technologies are with this agent approach. So you're ramping up an agent. This agent is manipulating the software you're using, and then they try to identify with machine learning and other techniques and pattern matching and all this stuff to identify there are different users or different actions that looks like an attack. And then you have two mode. You can just monitor it and alerting, and the other thing you can proactively just stopping this application. So this is the RASP. So it's really protecting the runtime production against ongoing cyber attacks. What is the best order to start? My personal opinion is that you should start with Zust, because this can you do with a minimum amount of knowledge about how to attack systems and all this stuff. If you have this in place and this is running, then you can start testing your environment with the approach of most common vulnerabilities, so Dust tools. And if you have budget left and you have the infrastructure and the possibility to use agent approaches, so it's this agent-based approach, then you can use RASP as well. Starting with RASP is mostly a very counterproductive system or a way, because mostly the developers and ops people saying, oh, if I'm missing something, RASP will catch it. And this is mostly not good for the quality and some other things. And having in mind, RASP is mostly on this agent approach, means if the whole production line is weak, you can get compromised agents as well. So you have to harden your whole tech stack against known vulnerabilities and compromising binaries before you are introducing the next level of manipulating automatically with some external dependency my production line. Okay, having this in mind, so Zust does RASP. If you ever be able to use IST, interactive application security testing, depends really on if you have the right skilled people in your organization that are able to do it. Okay, back to the application. If you want to now to start, and the easiest way to start is Zust. Why? And why this is good. So if you're looking at the whole tech layer, applications, how much lines of code or how many lines of codes you are writing by yourself and how many lines of code you're adding as a dependency. Most likely it's in a way that you have a huge amount of external lines of code, grabbed via dependency, compared to what you're writing yourself. So even if you're writing 1 million lines of code, your dependency in the most environments I saw, not always, but the most environments, is just a huge amount of, or potential amount of these lines as a dependency. If you're going to the operating system, it's even worse. You're writing a few configurations. You're not writing a kernel driver, mostly. Some people, yes, but mostly you're not writing a kernel driver. And the rest of the operating system is a binary you're grabbing, and there's a huge amount of lines of code. So it means your configuration, a few lines of code, again, this amount of lines of code that you're grabbing from outside. Docker is the same. You're writing a Docker file maybe, and the first statement is from. So it is a dependency anyway. And then you're going to the Kubernetes layer and then Helm charts and all this stuff. So looking at all this, the amount of stuff you're doing by yourself and the amount of stuff you're grabbing as an external dependency, looking at the whole tech stack, is the balance between, in this way, that the dependencies are the most dominant thing. So make it sense to scan your own source code against known vulnerabilities with SAST, to have machine learning running on your own source code? No, because it's a tiny part. And the tools that are scanning with machine learning and all this stuff, your source code, they are missing a little bit the context. You can have best practice, and you should write code in best practice. Make sure that you're not just using all input fields and just pushing it to the database, SQL injection, not reading just binaries and executing everything. And so, okay, that's fine. Do this one, but analyzing your source code with tools extensively would be the wrong focus. Focus on the dependency, because it's just the biggest part. And then it is a part of SAST, static application security testing. And again, what the most environments are forgetting, the DevSecOps part. Check your compiler, your scripts, your CI environment, your whatever. So everything you're using internally is, with this attack against supply chains, a target. So you have to harden your CI environment. You have to scan your Jenkins. You have to scan your TeamCity, whatever. So scan your environment, everything. Okay. We have two things that are competing for recognition. No, I'm missing the word. Sorry. So, but we have two things that are here in the field. So it's compliance and vulnerabilities, and we have different behavior. So compliance, if you want to start with compliance scanning, the machine is very good to scan all binaries. And for this, you need to understand dependencies and their direct and indirect dependencies. So it makes sense to analyze the meta information and then see, okay, this dependency will have this dependency and this dependency and so on. And then the machine can scan for license issues. So for compliance, that's easy. But the initial work here is that you need someone who's able to decide what is a good license and a bad license for this part of the supply chain. Okay, this is the initial thing, and then you can feed with this the machine, and the machine can just doing this ongoing job in a very fast way. Make it sense to scan again and again against compliance? Yes. Looking at different projects, for example, a very prominent one is Jakarta EE. So Java EE was Jakarta EE, is now Eclipse EE, and is now was Eclipse EE, and now it's Jakarta. I lost the overview. So we have this one. So moving big projects. On the other side, there is a dependency, and internally he's using maybe some collection library. And then he decides to switch to another collection library because it's cool. Then it's not good to trust this developer that he will do the compliance work perfectly. So you have the same dependency in a new version, but indirectly you're consuming a different dependency. So it makes sense that you are scanning this stuff on a constant, on a frequent base. Vulnerabilities is a different beast. So the initial effort is zero. Just say, there are the binaries, do it, scan, that's it. The machine is scanning. On the other side, you will find very often vulnerabilities and not so often compliance issues if you fix it once. And then you have to do what's going on. The compliance issues, they're tricky. So you have a compliance issue, and then it's a single dot in your whole tech layer, so the whole thing. And the only thing to get rid of compliance issues is you're removing this part and replacing it by a semantic equal implementation with the same functionality. Yeah? And this is sometimes really a piece of work. Yeah, so that's one thing. But if you have done it once, mostly it's quiet. It's not changing so often. Another thing is vulnerabilities. Vulnerabilities, to get rid of vulnerabilities, you don't have to change the implementation against a semantic equal one, you can just use a different version of this dependency. And this means that the full amount of vulnerabilities or attack vectors are based on the whole composition of versions. Because the weak point with vulnerabilities is you have in different layers different vulnerabilities, and they can combine to different attack vectors. So it makes no sense just to scan one layer, just Docker images or just whatever, Maven dependencies. You need the full understanding. Okay, this jar is in this web archive is used in this Docker layer, this is used in this Docker image, and this was used by this Helm chart and running there. So you need the full understanding to know where all these weak points are and what are the possible attack vectors against your system. Okay, but let's talk a little bit about the lifetime of vulnerability to understand what is the best part where you could speed up the whole fight against vulnerabilities. People are creating vulnerabilities accidentally or on purpose. Can we change it? No. I can work on myself to use best practices, but it could happen that I'm creating a vulnerability. Okay. So next thing is, what is the first time we know? So if this vulnerability is found, someone found, oh, there's a weak point. Then the next thing is, if he is a good one, he will try to make this information public available somehow. If he is a bad one, he will use it for himself, selling on darknet, using it for his own attack, whatever. So if it's found by someone who is bad, yeah, so the bad hacker, then for me the lifeline is more or less invisible. I can't do anything against it because it's somewhere. It's there, it's found, but from the wrong person. If it is found by someone who will push it to a vulnerability database so that it could be consumed by everybody else, and that's a good way. So the lifeline of this dependency is visible for me now. So I'm now a security researcher. I found a very critical thing and now I try to sell it. What is the best way or whom I will sell it? Okay. The first thing is that this is amount of money. I can spend this money or I can earn money with this one. And now I will decide who will give me the most money of this. If it is vulnerability database 1 or 2, I don't know. So sometimes I will sell it to A, sometimes to B, and I will just do it with where I'm getting the most money. So what does it mean? If I'm focusing on one vulnerability database, it's always a subset of not dependencies, a subset of vulnerabilities. Why? Because I have no clue if it is sold to this one or that one. So whatever dependency or vulnerability database I'm using or choosing it will be the wrong one. We at JFrog learned it in the same way and we know it. And so the only thing what is possible to work around this or to get this one, you have to build a superset. So if you are deciding to consume you must decide what vulnerability database you are consuming. Otherwise, you don't have the information. You have to make sure that you're using a superset to get the biggest umbrella you could get. So just one single vulnerability database is not enough. You have to combine different resources. And this is exactly what at JFrog we are doing. We have our own security research. We have vulnerability database, free one, open source one, commercial one, and so on. And with this one, now this work will start. The knowledge of this vulnerability must be transferred in a consumable way. So it must be available. So not only is the info is public available, it must be consumable and consumable by you. And here is, if you like it or not, mostly the free vulnerability databases are smaller and slower. Why? Yes, the security researchers, they want to earn money, so they are not giving it for free. They are mostly selling it. Means you need to spend, if this time is critical, if you want to speed up the time from the knowledge is there and you can consume this information. If you want to minimize this amount of time, you have to spend some money or to find another way how to get to this information. But most likely the free ones are slower. We can endless discuss if this is good or bad or whatever, but that is economy. And now the information is consumable. So you have the whatever you're choosing, the free one, the commercial one, A or B or C or whatever information pool you're using, now you have the information. So now the time is running because from information is consumable, time starts running, to fix in production. That's exactly where you should focus in the beginning. It must be automated in CI environment, it must be fast and all this stuff. You need to have lean processes so that there is no approval process and all this stuff is blocking this one. So information is consumable until fix in production. That is where you should focus first on, so that you have the most impact out of it. Okay, now as a developer, what is the best safety belt you have? And this is really true. So against vulnerabilities or compliance issues, the best safety belt for you as a developer is good test coverage. Why? If you have to replace an implementation with a semantic equivalent, what's the best safety belt? Test coverage, because then you can change first and verify that's running in the same way. If you have to build a new composition of the same dependencies to get rid of vulnerabilities, could be in version increase or decrease, the whole composition must be with less vulnerabilities or less critical vulnerabilities, means you need a good test coverage to change the version, let the test coverage run, and just push it to production. I'm a big fan of mutation testing because this is a very strong test coverage. Identify what's working best for you. If you want to check it on my YouTube channel, I have the explanation what's mutation testing and how to run it and the basics and the theoretical part behind it. But whatever it is, the best weapon against known vulnerabilities and compliance issues is very effective dependency management, because this has the biggest impact because you are working with 99% of your whole test stack. Huh? And as a developer, a good test coverage is really what you need. So back to the previous thing, what is the best place to start with this? If you want to have all known vulnerabilities in the whole tech layer, you need a single point where all binaries are running through. And this single point must understand not only the binary, it must understand the meta information as well. So this dependency has the next dependency, has the next, and so on. And if you have the possibility to read this metadata and you are understanding the full impact graph, then or the full dependency graph, you can create the impact graph of vulnerabilities. And this is exactly what we are doing with Artifactory and Xray. And if you want to try it, I have free workshops where you can just register, and I have it every few weeks. I have this one. And you can use Artifactory and Xray for free in the free tier. So check out for free tier and then register and use this binary storage with a security scanner. If you want to know more about the product, how to use it, feel free to check on my YouTube channel or go to one of my webinars. Then I'm explaining the tool itself and how to do it inside an IDE, for example, so with an IDE plugin. So very cool stuff, but the right place to start with security is where all binaries are running through. And if you're doing it for your production, why not using it for your infrastructure as well? So if you have a router that's consuming Linux, then use Artifactory as well to grab these binaries over Artifactory to make sure that you can scan all binaries that are coming through, and so on and so on. So don't focus it just on dependencies for your app you're creating. It's all infrastructure run over it. It's the best way, because then you have really the full impact graph over all components of your supply chain. Okay, so slowly we are coming to the end. So if you want to win a JFrog t-shirt, the first 15 will get it. It's jfrog.co Istanbul t-shirt. Yeah, you can stop the video at this point to write it down, or I will write it in the comments maybe so that you can do it. And then you will find the slides. And have in mind, if you want to hear this stuff in German, go to my German YouTube channel or go to my English YouTube channel, Sven Ruppert in English. So I really would like to get you as my new subscriber. If you have any feedback, contact me via LinkedIn, Twitter. Don't use email, that's just a mess. But all this social media stuff works fine. So if you have any questions, feel free and connect. And I really would appreciate to have a discussion with you about the pros and cons and all this stuff. And at this, I can just say thank you very much for attending. Whatever time you're looking at this video and watching it, I can say enjoy the rest of the day. Stay safe and see you somewhere virtually or maybe real in the future. Okay, so I think I'm done with my topic.
Yeah, thank you, Sven, by the way, for your time. And it was a really cool and helpful session. I can say that. So, yeah, if you have any kind of question, you can ask on the channel so I can reflect it to the screen. So, yep.
Okay.
maybe a couple of minutes we can wait. Maybe I can also add something, because especially everybody nowadays using the containerization technologies, right? We are using Docker images everywhere. And in order to store our Docker images, we are using different kind of, maybe your on-site registry, maybe software as a service. So for example, I'm using Core.io, let's say that, just an example. They are doing Docker image scanning. And then let's say that I am using JFrog for my Artifactory, and I can also store that part. So you mentioned the diagram about this DevSecOps, and it is kind of compatible with Helm, Maven, different kind of Artifactory tooling. So can we say that, for example, on the Docker image generation side, I am already scanned my image on the Core.io? How can we just eliminate the duplications? I mean, my image already scanned on the some kind of third-party service, and I don't want to make it run on the JFrog side, for example. Do you have this kind of integrations? So instead of let JFrog scan my image, just provide the integration, let's say that it can be fed by some third-party service.
So first of all service we have, they're available via command line interface and REST interface, okay? And all components have webhooks, so you can start external processes to do something. And with REST interface and webhooks, you have the possibility to create dynamic workflows. Whatever this workflow is, we have a ton of integration to different third parties. I don't have all of them in mind, so I really have to check somewhere in the list what's available. But if you want to scan just Maven and Debian, then for this repositories, you can activate Xray. And if you don't want to scan Docker images, then don't activate Xray for Docker images or Docker repositories. So you can very fine-grained decide what should happen. And on the other side, if you have the third-party tool and they're scanning something, the cost of scanning inside Artifactory, the Docker image itself, again, is not really huge. Yeah. So it's a trade-off what you want. And you have different ways to scan. So first of all, you have this classical thing that you have these policies and rules where you're defining what is necessary. So if I have something with a CVSS value, A or B, break a build, send an email, blocks the download, whatever. So different things you can start. And on the other side, you can use this information inside your IDE as well. So with this IDE plugin, IntelliJ and VS Code and Eclipse and whatever. And then you have this information about vulnerabilities already inside your IDE. So you're adding inside your POM file a dependency, Jakarta, Kubernetes, whatever. And immediately you will get the information, okay, in this version and all dependencies from this dependency you are adding, you have the following vulnerabilities. And then you have it in your IDE already. So way earlier before you're creating a Docker image anyway. And this is something I really would recommend, that for the technologies you're using, try to identify it as early as possible. So often I see that they are working 2 or 3 days, creating a Docker image, and then they see there's a vulnerability inside the, I don't know, Java layer, for example. And this is just a waste of time because you spend already so much time to create it, to identify there's a vulnerability, and then you have to remove it. So with all the security stuff you're doing, whatever you're using, try to do it as early as possible. And the best way for me as a developer is I need this information straight away inside my IDE directly. If I'm adding a dependency, and if I see, okay, version 2 has this vulnerability, I have to go back to version 1. I'm doing it immediately, encoding against this one. Okay. So that's something. It's a mindset how to deal with security, and it's a functionality. Everybody in the DevOps team has a dedicated part where he can efficiently work against security issues. It's like quality. If you're doing crap in the beginning, it's hard to do it later. So it makes really sense to do it as early as possible. And everybody, the developer is managing dependencies. The ops people are running, scanning configurations and the operating system, and so on and so on. I see there is a question, or
Yeah.
what about a vulnerability is discovered after the application is published in public available? Did you cover any such scenario in real life?
I think runtime scanning or something like that.
So you have different approaches to this one. So first of all, this SolarWinds hack was something like this. And what they introduced with the executive order of cybersecurity from Mr. Biden is that the US government now wants to have NASBOM. It means a full list of all ingredients of the software that is consumed or run by the government. Why they want to have it? Because they want to have this dynamic information like, okay, there is a vulnerability, and then they want to identify what part is infected somewhere, okay? And we have this since a long, long time. It's called build info. And this is a combination between static immutable data and active data, warm data, the vulnerability databases. So if you have an image and this is pushed already, to scan production against vulnerabilities is semi-optimal because you have the knowledge of what are the ingredients and what is a place to let this image run. So there is no need to scan production. This would be a performance issue, it would be a weak hole where you can sneak in and so on. So I would prefer something like, I know exactly where my images are running and I have this information immediately after an update of vulnerability database, and then I have to fix it anyway. Until this time I can decide I have to shut down production or I let it run and I have to prepare or to provide and fix as soon as possible. I'm not sure if I really covered your question here. Just let me know if this was an answer to what you ask here. So, okay, any I don't know how much the delay from StreamYard to YouTube is, but I think just a few seconds. So if there is anybody with more questions, just write it in the comments. I will see it here quite soon, I hope. Okay.
Yep. I think there is no other question, so maybe we can finish.
Yeah. So otherwise, I'm available, social media, internet, everything. Don't try email. Please don't use email. That's very important. It's a mess with email. But everything else is fine. So connect via Twitter or on YouTube. That would be perfect. And then you can ask anyway. Even if you see this video in 2 weeks or 3 weeks, feel free to contact me. So, okay. Any questions from your side? Or we are more or less done?
We are done. We are done. Yes.
Perfect.
Thank you, Sven, again for your time and for your valuable information about on this domain. So thank you, everybody, and have a nice evening, have a nice day. See you in the next event.
Okay. Bye.
Bye.